Consider the system of linear equation of three variables, and to solve these equations by Gauss-Seidal iteration method, first of all, we have to identify the coefficient of x, y, and z. In the first equation, if a1 is the greater than the coefficients of b1, coefficient y, and coefficient of c1. In the case a1 is greater than the coefficient of y b1 and the coefficient of z1, then from the equation 1, we determine the value of x 1 by a1, which is equals to d1 minus b1y minus c1z. So this is the first equation. In the case b2 is greater than or equals to a2 plus c2. b2 is the coefficient of y, which is greater or equals to the coefficient of x, which is a2, and the coefficient of z, which is c2. In this case, we find the value of y from equation 2, y equals to 1 by b2, which is equal to d2 minus a2x minus c2z. This is the equation 2. And in the case of c3, which is the coefficient of z, greater than or equals to a3 plus b3, in this case, we find the value of z, which is equals to 1 by c3 d3 minus a3x minus b3 y. Gauss-Seidal iteration method. In the Gauss-Seidal iterations method, first we assume that the initial guess of the values of y and z. So the initial guess y equals to 0 and z equals to 0. So we get the first iteration, the value of x, y, and z. In the first iterations, the value of x, we write here 1. This is the value of x in the first iteration, which is equal to 1 by a1 and d1 minus b1, y, the initial guess of y, which is equal to 0. So we write here y0 minus c1, the initial guess of z, which is the value of z, 0. And in the first iterations, the value of y, we write in the first iterations, which is equals to 1 by b2 and d2 minus a2x. The value of x, we use the value of x in the first iterations. So we write here the value of x in the first iteration, but the value of z of the initial guesses, z equals to 0. So this process is called Gauss-Seidal iterations process. So in this case, the first iterations, the value of z1, which is equal to 1 by c3 and d3 minus a3x, we use the value of x of the first iterations, value of x, the first iterations here. In the second iterations, x2, we use the value of y and z in the first iterations. So x2 equals to a1, which is equals to first iterations. We write here 1, we write here 1. So in the second iteration, the value of y is second iteration. So we write here x2, the value of x from second iteration, and the value of z from the first iteration. So in the last, the value of z, and this iteration which is second. So we find the value of z in second iteration. We use the value of x and y from this iteration. The value of x in the nth iterations. The nth iteration is 1 by a1 d1 minus b1 y minus c1 z. Here we use the value of y and z of n minus 1 iterations, n minus 1 iterations. So the value of y in the nth iteration, we find 1 by b2, which is equal to d2 minus a2 x. We use the value of x from these iterations. So we write here xn minus c2. We use the value of z from the n minus 1 iterations. And the last one is z, the nth iteration of value of z is obtained by using the value of x in this iteration. So we write xn and the value of y from in these iterations. So we write here for n equals to 1, 2, 3, x plus y plus 10z equal to 35.61. Applying Gauss-Seidal iteration method correct to 2 decimal places. So in this case, from the first equations, we find the values of x because the coefficient of x is greater than or equal to the coefficient of y and the absolute value of coefficient of z. From the second equation, we find the value of y, and the third equation, we find the value of z. This is the equation of 3. So from the first equation, we find the value of x. And from second equation, we find the value of y. And from third equation, we find the value of z by Gauss-Seidal iteration process. In this process, initial guess, we assume that the solution of the system, which is y equal to 0 and z equal to 0. Using y equal to 0 and z equal to 0 in the first equation, we find the value of x from 1, which is equal to 1 by 10, 11.19 minus y equals to 0 and z equal to 0. From the initial guess, we obtain 11.19 by 10, which is equals to 1.119. And the value of y in the first iterations, we obtain from the equation 2, which is equals to 1 by 10, equal to 28.08 minus x minus z. We use the value of x from the first iterations. So here we use 1.119 and minus z, and the value of z, we use the initial guess, which is equal to 0. Value of z from the equation 3. In equation 3, 1 by 10, which is equal to 35.61 plus x. We use the value of x from the first iterations, which is equals to 1.119 and minus y 2.6961, and this is equals to 34.030329 divided by 10, and this equal to 3.40329. This is the value of z in the first iteration. We use to find out the value of z, the value of x and y in the first iteration. X in the second iteration, we use the value of y and z in the first equation to find out the value of x. So this equal to 1 by 10, 11.19 minus 2.6961 and 3 plus 3.40329. we obtain 1.1897. Similarly, to find out values of y in the second iteration, we use the value of z from first iterations and values of x from the second iteration. From third equation by using the value of x and y in the second iterations. This is the value of x in second iteration and the value of y in the second iteration. We find 3.4451. In the third iterations, the value of x we obtain by using the value of y and z from the second iterations, which is equals to 1.2286, and the values of y in the third iterations we find from the equation 2, which is equal to 1 by 10, 28.08 minus x. We use the value of x from third iteration and z from the second iterations, 1 plus the value of x and this value of y. We obtain 3.4498 in the. We also find the value of x by using the value of u, y, and z in third iteration, which is equals to 1.2299, and the value of y is obtained by using these values of x and the value of z from these third iterations. We find 2.3400, and the value of z from third equation, which is equals to 3.4499. So in this fourth iteration, our procedure is in because there is value of z. Similarly, the value of y, there is two terms after decimals are same. In the values of x, there is also two terms after decimals are same. So our procedure is in, and the values of x is x equal to 1.22 and y equals to 2.34 and z equals to 3.44. These solutions are the accuracy of correct two decimal places.